Our next topic is going to be fundamental quantities. Actually, there are 7 fundamental quantities: length, mass, time, temperature, amount of substance, luminous intensity, and current. And their corresponding units are: for length it is going to be meter, for mass it is going to be kilogram, for time it is going to be second, for temperature it is going to be Kelvin, for amount of substance it is going to be mole, for luminous intensity it is going to be candela, and finally for current it is going to be ampere. Right. And these quantities are called as fundamental quantities. What about the other quantities? Other quantities like area, volume, all these are called as derived quantities. We call them as derived quantities. These derived quantities are obtained from fundamental quantities. Right? When you go to a shop to buy a cloth, you have to measure it in meter, right? And when you go to a grocery shop, you want to weigh something, you ask the shopkeeper in kilogram. When you look at the clock, you just see the time in hours, minutes, but actually the SI unit is seconds. Then when you get a fever, you have to notice your body temperature. In general, there are many scales. We use Celsius scale, we use Fahrenheit scale, we use Kelvin scale, but the SI unit is actually Kelvin. When you measure your body temperature, we use Fahrenheit. But you have to remember that when you are going for problems, solving problems, you have to use temperature in Kelvin, right? And next one, when you are doing an experiment, you are not going to say 1 kilogram of carbon dioxide or 1 gram of water. We use it as we take 1 mole of carbon dioxide or 2 moles of water. Next one is going to be luminous intensity, and that is measured by candela, and current is measured using ampere. And in the previous ancient period, they used a lot of systems for units. They used CGS system, and they used MKS system, they used FPS system, and we have some expansions for this. CGS, centimeter, gram, seconds. MKS, meter, kilogram, and it's going to be second again. And the FPS is going to be foot, pound, and second. So length was measured using centimeter, meter, foot, whereas mass using gram, kilogram, and pound, and time they use seconds. And finally, all the scientists, they came to a conclusion that throughout the world they have to use the same unit for length, and the same unit for mass, and the same unit for time. So they finally introduced a new system of units which is called as SI system. What is SI? It is going to be System International. So that is the expansion of SI. Now universally throughout the world, everyone uses this SI system of units now. And next we are going to see about a scientific notation. So this is very important while giving your answer. Finally, actually this scientific notation is to be used in our problems, right? Generally a scientific notation is represented as n into 10 to the power of n. where n is a number. Here n is a number and it is a non-zero number. That is very important. It is a non-zero number. N is a non-zero number and small n is an integer. I am going to give an example. We will take example 1. In example 1, we are just going to take a number 0.00078. Now I am going to express this in scientific notation as 7.8. So how many decimals I have moved? 1, 2, 3, 4. So into 10 to the power of minus 4. So this is the correct way to write it in scientific notation. I am going to give another example for that. Example 2. For example 2, I am just going to give you another number 345.83. So this is a normal number. I am going to give it in scientific notation. I am going to write it as 3.4583 into 10 to the power of 2. Now I have moved 2 decimals this side. So I have to write it like this. So this is the correct way to write it in a scientific notation. And finally I am going to give another example. Example number 3. 3500. How to write this in a scientific notation? I am going to write it as 3.5 into 10 to the power of 3. So this is the correct way of writing it in a scientific notation.